Our dear students in language school, good evening for all. Today we will continue what we have started in previous lessons about digitization. This is Mrs. Rania Mahmoud al-Naggar, and our lesson today is about digitizing of images. Before we start, let's know what we mean by digitizing of images. We know that images is a data type, a type of data that we entered to computer through capturing images by camera or drawing images by a painting program. So how we will convert these images to a binary data so we can measure how much amount of data it occupies on storage disk. Before we start, we want to know what is the meaning of the pixel. The pixel is the smallest unit that compose an image, mean that the image composed of pixels. A pixel is represented as a square, small square, composed of dots, As you can do this, you can classify the images to raster and vector graphics. A digital image is represented by the arrangement of pixels. You can convert your image to some pixels, some of vertical pixels and some of horizontal pixels. Let's see the procedures of digitizing images. Images can be captured by digital camera or image scanners. Then images can be digitized and imported into computer through the following process. See the shape, the original image as we see in the left corner of the page. This is the original image. It may be a complete image or a part of image. The original image or the part of image, we first sample it. How we can sample it? We can divide the original image into a group of pixels. Each pixel, as we said, is a square, and the picture will be divided into equal squares. Each square is called a pixel. Then we move to the second step, which is quantization. Quantization means that we can divide the pixels into a group of numbers according to the depth of color. See, the color here is lighter. The color here is heavier. So we quantize the picture according to the depth of color. Then we convert these numbers to what we call binary data, which the step is called encoding. Let's see in details. The first step is sampling. What we mean by the word sampling? Sampling means that the image is divided into pixels, and each pixel represented in brightness, which is extracted, means we have to show how the depth of color is extracted. See, in previous slide, we have seen these pixels. This pixel is lighter, this pixel is heavier, so the brightness is extracted. We here see how the gradients of this brightness. Here we should introduce the definition resolution, the degree of fineness of pixels when sampling. The unit of resolution is called dpi. So how we see dpi is, it is sometimes expressed as vertical pixels multiply horizontal pixels. So the dpi or the resolution is equal to vertical pixels multiply horizontal pixels. So the first step, sampling, it means to divide the image into pixels, and we see how the brightness here is extracted from lighter to heavier. Then we should multiply the horizontal pixels by vertical pixels to show the DPI, or the resolution of the image. Now, in second step, we see how we can quantize the image, how we can convert the brightness of each pixel into a numerical value. How could we make it? By dividing the pixels levels to several levels according to the brightness. We see here in this table that numbers started from 1 to 4, then in second level from 2 to 5, in third level from 3 to 6, in fourth level, which is heavier, from 4 to 7. The gradation here means that the level value represents the intensity of color per each pixel. The intensity here means حساسية الضوء أو depth of color. The gradation is determined by the number of bits allocated in each pixel. At 2-5 fixed gradient, which is meant 8 bits, it is represented by 2-5 fixed levels that started from 0 to 255. Now moving to the third step, encoding. We already quantize the values in binary number, so we will convert the numbers from 1 to 7 to the equivalent binary code. Started also from this is equal to 1. 001 is equal to 1, equal to 2, equal to 3, equal to 4, then here 2, 3, 4, 5, then 3, 4, 5, 6, then 4, 5, 6, 7. So we will convert the binary data into equivalent binary numbers. How we could calculate or measure the amount of image? We agreed that we have the DPI, which is equivalent to number of pixels, vertical pixels, multiply horizontal pixels. Now it's time to multiply this to the number of bits for color information, to the depth of color. This is what we need to calculate the amount of data image. The higher the value of resolution and gradation, the smoother the image obtained. The higher the values of resolution means the higher the number of pixels, the higher the number of pixels is how you should convert your image into many pixels, into many levels as possible as you can, as possible as your Vega could do. The smoother the image means that the image is smooth, not sharp, and it has many details. So it has many colors. So the image of this classification will be a high quality image. The quality of image improves, but the amount of data will be increased. The more details we have in this image, the more colors we have in this image, means that we have more amount of data. Here we can say that PMP images, which are Windows images of high details, of high colors. So it has a very large amount of data. It occupies a higher storage data, but we can't use it on internet. On internet, we need smaller pictures. We need smaller pictures to be easy loaded. So images on internet are of less details. So it is of less size. Okay, so when we calculate the amount of image, we should multiply the number of pixels, which are vertical pixels, by horizontal pixels, by the depth of color, which is mean the number of bits for color information. And we must know that the higher value of resolution and gradation means to divide it to more levels. The smoother the image, means it has many details, it is not sharp image, and it is of high quality image, and it is of high amount of data. Let's see an example of how to calculate the size of image. What is the data amount of 24-bit full color? This is the depth of color with a resolution of 1280 multiply 720, means the number of vertical pixels and the number of horizontal pixels. He wants to calculate the data amount in megabytes, and for this question, assume that 1 kilobyte is equal to 1000 byte, not 1024, and 1 megabyte is equal to 1000 kilobyte, not 1024. So we should round our answer to 2 decimal places. Let's see how we can calculate. First, the amount of data is 1280 multiply 720 multiply 24. So the result will be 22,180,400 bits, because we multiply here in 24 bits and we calculate here by pixel, and pixel is represented in bits too. The answer is clear. The pixels are represented in bits. The depth is represented in bits. So the result will be in bits. Now we have the result in bits. We want to convert it to kilos and then to megas. How we could do? Since 1 byte equal 8 bits, so we should convert first 2 bytes to 22,118,400 divide 8 is equal to 2,007,600 and 800 bytes. Now it's time to convert to kilos, then to mega. 1 kilo equal 1000 byte. 1 kilo equal 1000 byte. 1 mega equal to 1 kilobyte. Therefore, the number of bytes will be divided over 1000 for converting to kilos, then over 1000 to convert to mega, which is rounded to 2 mega 0.7. Now it's time to differentiate raster format and vector format. What is raster format? Raster format is the pictures that is captured by cameras. So it is used to represent text with shapes. Appears jagged. When enlarged, its appearance is called jagged. Jagged here means pixelated. Sometimes we say that the image is not clear enough. We say مبكسلة. بنقول الصورة مبكسلة. That means jagged. Images are drawn using painting software. So this type is not raster. It is vector. So vector is a representation that includes information about the coordinates. Points compose the image because the image here is drawn, not captured. So we are calculating the size by the information about the coordinates of points and the angles. And also the thickness of lines connecting the drawing. Images are drawn using drawing software. So the images captured by cameras, we call it raster format, and we deal with it using painting software. The images drawn by tools is being measured by the coordinates of points composing the images, as well as the angles, as well as the thickness of lines, and we deal with them using drawing software. Now let's see how colors can be represented. How colors can be represented. We have many methods. First one is three primary colors of light. The three primary colors of light are red, green, blue. When we mix these colors, the brightness increases and approaches to white. Here, we measure the picture by RGB system, red, green, blue, which is referred to red, green, blue. And the measures or the number of pixels are from 0 to 255 only. So when RGB is equal to 255, then 0, then 0, the color is fully red. R. This is for red. So what about green and blue? You can see that green is 0, 2, 5, 5, then 0. So the image color here is totally green. Now the blue color is represented as follows: 0, 0, and 2, 5, 5. This is for blue. Suppose we want to see how white measures. It is 255, 255, 255, the mix of the three colors. So how black is represented? It is of 0, 0, 0 color. So the three primary colors of light triggers most of the colors we see by mixing the three values of the RGB system. Okay? Now moving to three primary colors of pigment. Here we see that these are three primary colors of light. الألوان الأساسية للضوء. Here, three primary colors of pigment. الألوان الرئيسية للصبغة. How we use this? The three colors of pigment are cyan, magenta, and yellow. and mixing these colors will darken them so they are close to black. These three colors are used in televisions. Now, the additive color mixing, a method of representing by combining three colors of light used in televisions and computers displays. And subtractive color mixing, a method of colors combining the three colors of pigment, and this is used in color printers. Now moving to the depth of color, 20-bit, 24-bit color. Each color of red, green, and blue is represented in 256 levels, and as 2 power 8 is equal to 8 bits, so we multiplied by 3, which are 3 colors, so the result will be 24 bits. So when we present the 3 primary colors of light, we represent them in 256 levels. Why? Because we use 2 power 8, which is equal to 8 bits, and then multiply in 3 because we have 3 colors here, so the result will be 24 bits. Means we use all the levels of colors. Now it's time to practice. Let us practice together. Rearrange the following steps from A to C in order of converting image into digital data. We have studied how to convert images, or the main steps in the procedure of converting images to digital data. Let's see. Replace the brightness level of region with integer value according to fixed rule. Is it number 1? No. Divide image into evenly spaced grid sections. Yes, this is the first step. We first divide the original message into evenly spaced grid sections, which we call pixels. Represent the integers in binary. Is this the first step? The second? No. The first step is to divide images into evenly spaced grid sections, which is called a pixel. Then replace the brightness level of each region with integer value according to the rule, and then represent them in binary. So the correct arrangement is P, A, and C. So do you remember what is the first step called? Yes, sampling. The second step is called quantization. The third step is called encoding. Don't forget. Choose all statements that correctly describe the digital representation of images from the options A to D and answer using letters. The raster appears as having noticeably jagged edges when the image is enlarged. The raster format is suitable for expressing images with clear contours such as logo. So, about raster, yes, the raster format appears as having noticeably jagged. When we enlarge the image, okay, it is jagged. We said it is judged means pixelate لما بنكبرها بتبكسل مننا. This is correct. But we use to express it with clear contour for logos. No, this is not correct. So it's about raster. A is correct and B is not correct. Now moving to vector. Vector format represents image by incorporating information such as the coordinates and the thickness of line. Yes, this is correct. But we deal with or we use painting software to create vector graphics. This is not correct. We use drawing software. So the correct answers here are A and C. The correct flow for digitizing an image captured by digital camera means we have a raster graphic from options from A to D and answer using letter. Do you remember the correct arrangement of the steps? Do we start with quantization? No, we don't start by quantization. So letter A answer is not correct. Letter B answer is not correct. So we start with encoding? No, encoding is the last step. We start with sampling? Yes, sampling is the first step. Then quantization, then encoding. So letter D is the correct answer. Okay. Now the following diagram illustrates the process of converting original image into digital data. Choose the diagram that fits into the blanks A to 3 from 1 to D. Now, which is the correct answer? Do we start with quantization? No. Do we start by encoding? No. We first make a sampling step, which is dividing the original message into a group of pixels, a group of evenly squares. Each of them is called a pixel. So the first step is D, which is sampling. Then we convert these squares or these samples to be quantized, to be measured by numbers. Here we have no light, no color. So we represent here by 0, 0, 0, 0, 0. Here we have lighter color. So all these pixels have the value of 1, the first degree of light. Inside we have heavier light, so we can represent it by 2. Inside we have only 4 pixels of heavy light, so we represent them by 3. You understand? Then after quantizing, according to sampling, we convert these values to equivalent binary numbers. So this is the first step, D. Then the second step, B. Then the last step, C. Let's see the answer. Yes, 1. The first step is D. The second step is B. The third step is C. And this is the correct answer. Now in these questions, assume that 1 kilobyte is equal to 1000 byte and 1 megabyte is equal to 1000 kilobyte. What is the data amount of an image in kilobytes? Here we ask about kilobytes. We want the result in kilobytes with a resolution of 800 multiplied 600. So this is the number of vertical pixels and this is the number of horizontal pixels, where each pixel has 8 bits. The depth of color is 8 bits. What will you do? Can calculate here the data amount. You have a calculator? We need to use calculator here. Okay, what is the result of this? Yeah, it is 3, 8, 4, and we have 4 zeros here. Now we should convert it to kilo. This is the data amount in bits. So we want to convert it in kilo. We need to divide this number divide 8, which is equal to 4. 1, 2, 3, 4. Then we should divide it by 1000 because this is in bytes. The result here in bytes. If we want to divide it by 1000, we should remove 3 zeros to get the final result, which is 4 megabytes. Let's see that the amount is equal to 3,840,000 bits, where 1 kilo is equal to 1000 kilobytes, 1000 bytes, and 1 mega is equal to 1000 kilobytes. The data amount will be 300 bytes, and then move to, we need first to divide by 8 bits and then to divide to divide to 8 bits first, because we measure here in bits, and then divide by 1000. So the result will be. Now, what is the amount of 24 bits full color with a resolution of 720 by 480 pixels in megabytes? The data amount is equal to 720 by 480 by 24, which is equal to, using calculator, is equal to 8,294,400 bits, and this is should be divided by kilobits to convert it to the kilo, then by meg. In this question, assume that 1 kilo equal to 1000 bytes and 1 mega is equal to 1 kilo. So now calculate what is the result. Now we have 424 bits and the resolution is large numbers. We need calculator. So the result will be in megabytes. Now round your answer to the decimal places. So that amount will be all numbers multiplied, then where 1 kilo is equal to 1000 bytes and 1 mega is equal to 1000 kilo. So the data amount will be, as we say, the result will be 198.2. And we would like to round it. It could be 189 plus 0, 3, if you want to do decimal places only. Thank you so much for listening and understanding, and I hope you practice well. Goodbye, everybody.